Did you get it? I just made you the host.
I'm recording now.
Boom. All right, great.
Thank you.
I gotta get my camera angle back right. Let's see. All right, can y'all see that? The board?
Yes.
All right. So we're gonna cap off this hydroxyl group with an acyl group, right? So the product, you can look this up, because I'm gonna need you to look up the molecular weight for aspirin or acetyl salicylic acid. I'm gonna write the name down for you, so don't panic about that. So it's OCH3, and then what we're gonna end up with is plus acetic acid. And this is acetyl salicylic acid. Right, that's what we're making, acetyl salicylic acid. That's the proper name for aspirin. All right, and so the way we're going to do this is we're going to take salicylic acid, we're going to take acetic anhydride. I can write the name of that down. This functional group is called an anhydride. You see how it's got an oxygen? It's almost like an ether, but it's got two carbonyls on either side of that oxygen. So that's called an anhydride. I don't know if we talked about that when we did functional groups. So this is a very simple experiment. What we're going to do, for those of you who have the handout, what we're going to do is actually cut all the values in half. All right. So instead of 13.8 grams of salicylic acid, we're going to cut that to 6.9 grams. Instead of 13.5 milliliters, is that what it calls for in the procedure of acetic anhydride? Is it 13 milliliters, something like that?
Yeah, 14.
14, we're going to cut that to 7. Everything is going to be cut in half so we can conserve resources. All right. So I want to have each group come up and weigh their stuff, but for you to demonstrate it, I'll go first. So I'm gonna move the camera over here for the Zoomers. And then let me blow this up. Okay, never mind. All right, you should be able to see the balance from here. So I'm gonna weigh your stuff out for you. So grab so this is the way we're gonna set this up. Let me show you that. So we're gonna take, everybody has a 400 ml beaker. So I want you to take that beaker and put about 100 milliliters of tap water into it. All right, so we have let me turn the camera back around. This is off. All right, so we got a 400 ml beaker and we're gonna put tap water. We're gonna use this to make what we call a water bath. All right, so that's how we're gonna heat this up. In organic, you do not use open flames. I know you use it in CHEM, but that's because you didn't work with stuff that was volatile. In organic, everything is volatile. Everything is giving off vapors. And if you light a Bunsen burner in here with this acetic anhydride, it's poof, be gone. Everybody, all of us gonna be somewhere, East Alabama or wherever. You know, it's gonna take about 3 hours, so I don't know how many of us gonna survive, but you always wanna use a hot plate and you never use an open flame, right, in organic. So we're gonna put some tap water into here so we can start our water bath. So go ahead and get that. It might be brown because we've been up in here for a minute. You gotta let it gurgle and kick and all that good stuff. Come on. This is the pipes, the iron in the pipes. I wouldn't drink it
Hasn't been used for a while.
a long time. Let me go over here with a mark, because this water's coming out too. That's all right. Mine. That's why I got distilled water. Come on. You know I'm an old man, man. Sometimes I'm trying to make sure y'all straight. But the OG might have to do something a little different. So we got a water bath that we're gonna set up. Turn the camera back around. So you can see on the hot plate, excuse me, we have a water bath here. We're gonna turn the hot plate on and start that water to boiling. So go ahead and turn your hot plates on and put the water bath on there, because while the water is heating up, you can be weighing out your stuff. One thing about lab is you want to be as efficient as possible. Everybody always asks, you really gotta stay at 5 o'clock? Well, you stay as long as you have to stay, but you can make the time a lot shorter if you actually work efficiently. All right. So I'm gonna grab my goggles because now it's about to get real. What heat do you have? I would put it probably on about between, what you got? Let me see which one you're working with. Put it on about 5. Yeah. You just want the water to be, now this is, you want this water to be boiling. If we're doing a recrystallization, which we're gonna do not next week, we're gonna take next week a gap and have another lab the following week, because I got a overlapping lab on Wednesday, so we can't meet again next week. But if you were doing a recrystallization, you would not want your stuff boiling, but this you want boiling. All right. So we're gonna heat that up, and while that's heating up, we're gonna come over here to the balance. Yeah, put it on about 5. What you working with? You got one of those, your white and gray ones? Yeah, put it on about 5. All right, so we got the balance. We have salicylic acid, which is right here. Let me get the camera. All right, I need everybody that's zooming, everybody that's here, look on the handout. You see that block that says molecular weight for salicylic acid? Put this number in there. 138.12 grams per mole. That way, when you weigh out the 138.12, did y'all hear that on Zoom? Salicylic acid molecular weight is 138.12. If you don't have the handout, don't worry about it. Just write the numbers down. And actually, I'm gonna put it on the board. And while the experiment is going, then you'll be able to copy it. No, the molecular weight never changes. Yep, the number of moles is gonna change, but the molecular weight won't change. All right, so 138.12. All right, acetic anhydride. You need the density as well as the molecular weight because it's a liquid, and you're gonna have to convert from milliliters into grams. So the molecular weight here is 100.06, and the density is 1.06 grams per milliliter. Molecular weight 100.06 grams per mole. Density 1.06 grams per milliliter. All right, put that in the box. The reason why this box is so important, this reagent table is so important, is because when it's time for you to calculate the percent yield and the theoretical yield, if you don't know the moles, and if you don't know the limiting reagent, then you're not gonna be able to do that calculation. All right, so we do all this stuff. That's what I'm saying about being efficient. You do all the preliminary stuff up front, get it out of the way, and then you just run the experiment and get the results. All right, so we're gonna wait. Go ahead.
Dr. Russell, you say you're gonna write the numbers on the board?
Yeah.
Okay.
So we're gonna wait. I'm gonna weigh this stuff out. Then I'll put the density and molecular weight of acetic anhydride up there, and then I'm gonna turn the camera facing the board so you can get all the information down.
Okay, thank you.
All right. So normally, let me see. Make sure y'all can see the balance. Yes, it's raggedy and old, but it's clean. So normally, what we'll do is we'll take a piece of wax paper or a weigh boat, and I actually like doing this better. This is cool. So we'll take a piece of wax paper.
The old school way?
Say again?
I said the old school way.
Old school, yeah. Trap house way. Don't tell nobody I told you that. Don't tell nobody. Don't ask me how I know it. I'm just do it. So we got a piece of wax paper on the balance. Normally we'll take a weigh boat, but weigh boats are very expensive. You can get a whole roll of wax paper for $5, and I've had this for like 4 years. So, and we're gonna weigh out 6.9 grams. Put that in the required, it says required amount in that box, 6.9 grams. And then for acetic anhydride, we're gonna do 7 milliliters. my screen? All right. So you're gonna weigh this out with a scrupula. And of course, if you took chemistry already, you should know you always got to zero this thing out. So we're gonna zero it out, and then we're gonna weigh out 6.9 grams. All right, we had 3.62, so I can kind of gauge and see how much I need. And just for the record, I'm the GOAT when it comes to weighing out stuff. I really am. Weighing and pouring. No, that's not up for discussion.
Might have to challenge you to that.
Come on with it then. What you waiting on? Come on, Cletus. All right. Get on up in there. Come on. Cooperate. Just in case you questioning my skills, what does that say? Can y'all read that?
Oh wow, 6.9.
Okay. I just want to make sure that y'all know who the GOAT is. That's all. All right. So we're gonna take this, and Caleb. Oh no, mind, I got your flask over here. You wanna take the flask here, and you wanna just deposit this into the flask, just like that. Don't ask me how I know about wax paper, weigh-in, or any of that. But I just know about some stuff. Come on up in there. All right. So I'm gonna leave that for now. All right. No. It's fine. It's gonna float. So you're good. All right. So we got. You can turn that down too if you want. Put it on about 3. So yeah, let me just weigh out the stuff, and I'm gonna come around with the acetic anhydride. So you can bring your flask though. Yeah. Let me weigh this out right quick. So everybody who's zooming, remember we weighed out 6.91 grams.
We don't use the same numbers. You want us to have.
They can be different.
All right.
I might be off on yours.
It's all right. I'm good.
We'll get close though.
So we put 6.91 for the actual amount column?
Yes. So the required was 6.9 and the actual was 6.91. Yes. Ooh. Goat status.
The goat need another 0.01.
No, you're good. You're good. So when you on yours, what you're gonna write is 6.89.
So is my stuff gonna be shared in our group?
Yeah. Yeah. That's why you're the representative of your group. So you got to make sure you take good notes and all that for the rest of the folks in your group. All right, we got 4 groups represented. So yeah. Actual is whatever this number that comes up. Come on, baby.
What about the people who don't have representatives there?
That's all right. I'm gonna put you in a group tonight.
No, like for groups 6 through 10.
You'll take the first number.
He's right here.
Okay.
Get me off there. 6.91. That's gonna be your actual amount. Come on, is it Jimmy name again? Okay. I was about to say the equation. Don't get mad at me. I'm the GOAT with weighing, but not with names. After a week though, I'll be good. All right, so for those of you who are watching again, you want to take that salicylic acid and deposit it directly into the early Mar flask. All right, and then so one other thing, yeah, you're not, but that's okay. I said 1 through 5. I try to be explicit with my directions.
She's a representative for 4.
Oh, y'all think I'm done. Y'all think I just jumped out the cabbage truck. Y'all got it twisted. Come on. All right. Come on. Go. 6.89. Too far off. I hit it the first time. Bruh, we're talking about some sig figs, like 0.1.
I put you top 3.
No, I'm gonna go B. Trust me. It's not up for discussion. All right. So the next step is gonna be hot plate lazy. It's hot though. The next step is gonna be to add, so we got 2 more steps. We're gonna add acetic anhydride directly to that Erlenmeyer flask. And then after we do that, we're gonna add some sulfuric acid as a catalyst. It says 6 to 8 drops. And what that sulfuric acid does, y'all can't see this, but what the sulfuric acid does, if you can see that on the board, the H2SO4, that's gonna actually protonate this oxygen right here. It's gonna do a proton transfer with this oxygen and activate it so that this hydroxyl group as a nucleophile can attack that carbonyl. So that's the purpose of the sulfuric acid. So we're gonna add first, we're gonna add the acetic anhydride, and it's 7 milliliters. So those of you who are watching, I'm gonna focus on this right here. You can see the flask on the table. And I got a little syringe I'm gonna use, and I'm gonna just come around each group or each man. Now your hot plate is not lazy; it's aggressive.
Put the work over here.
Yeah, I feel you. I feel you. Goat status.
Yes, sir. Those recognizes goat.
You heard it. So 3. So we're gonna add this directly. In the handout, it says to add the acid on an ice bath, but we're working on a smaller scale, so we're not gonna have to cool it down. All right, so don't worry about that part in the procedure. Everything is good. Take my word for it. All right, and this reaction is done under what we call neat conditions. That means there's no solvent. Right? It's neat. All right. So that's 7 mils of acetic anhydride. Hopefully y'all can see me. And then I'm going to add in 6 drops of sulfuric acid. All right. So that's six drops of sulfuric acid.
Dr. Russell, where is the handout for this? What is
It's on
it?
Blackboard, course documents, weekly experiments. It's the first handout in there.
Okay.
All right. So now, once we've added the acetic anhydride and the sulfuric acid, we're going to take this flask. I'm going to have to bump you up a little bit because you want it to stay hot. If it cools off too much, it won't dissolve. It won't. The reaction won't go. So we're going to take this and we're going to add it right to the water bath. Sit it down in there. And what we're going to do is we're going to heat it until it goes clear. So let me show you. Let me zoom in. Right, you can see right now it's not clear. Right, it's cloudy. But the longer you heat it, the more reaction is going to go. So we're going to leave it in the water bath, and all you got to do is swirl it. Every now and then, I want you to swirl it to keep it mixed. All right. And I'm going to keep the camera right there. And I'm coming around to the other groups. Let me come over here to the work with. Okay, next one. Okay, good.
So we have cut, yeah.
Yeah. That's set.
I was like,
That ain't about, the catalyst,
mhm.
yeah. It's not a change in brain. That's not what we consume. We're gonna regenerate that sulfuric acid at the end every time.
Will the next groups do the same lab or will be doing a different lab?
You know what? That's good. You talking about for next Tuesday? Or
Right,
next time we come?
right.
Yeah, y'all will be doing the purification part.
Okay.
So just keep swirling. You want it to go clear. When you swirl it, you want to keep watching it, make sure that everything goes in solution.
No, it's not white.
Huh? You should be able to smell like you smell a vinegar type smell. That's that acetic acid getting generated. You're gonna have to turn yours up some more. You see how it's going solid? Yeah, you gotta turn it up.
I turned it up to 7. Should I turn it up more?
No, that's fine. You just need to get that water to boil. That's the problem. It's not hot enough, and if the water is not hot enough, it won't go in the solution. I just started to go in the solution here. It's still solid. Yeah, that water is just it's not hot enough. That's all right. We got a fix for it.
I'm done.
It's going in.
Yeah, I'll say that. That's all.
And you want to swirl it until it's all the way. Once it's clear, you want to keep it on the heat for another 5 minutes.
Oh,
Not
God.
touching that.
You can turn that off, actually. That you got an old gangster out there. What's going on there?
All of that going on.
Said you had to use that to work, but yeah, I'll put it in work. in that. So they go through. All right, comment the rest of you up here.
Yes, mine's not.
5 more minutes for you, Amari. That's good. You don't have to swirl it, just sit, let it go, and just twist it. Yeah, twist it like you turn a knob. Yeah, just twist it. There you go, twist it. Yeah. Let me show you. It's right here. Just want to twist it, like you turn the knob, like that. Like, so keep that water hot, because if the water's not hot enough, it's gonna solidify, which is what it just did up here. This thing has been cooking too. Come on now. It's trying to boil. Yeah, we can.
It's still boiling on zero.
It's coming. It's about to boil. Now watch when it start boiling. It's gonna be through the roof. Don't. We got it. You with the OG. We got it. We've been doing it for a long time. I only had 2 accidents in lab the whole time I've been teaching here. 15 years. One was a student, we were doing a reflux and a student turned the transformer up too high and their whole thing just exploded. So we had to evacuate the 3rd floor. The other accident was we were doing aspirin recrystallization and they were heating up ethanol and they heated it past the flash point. Yep. And the whole thing was just had fire coming out of the top of the Erlenmeyer flask. It's about to boil now. So once it starts boiling, it'll go in the solution. You should be good. You clear over there almost?
Not yet.
Close? Is it going in?
Yeah.
All right. Let me get a different one right quick. So for Amari, you can see here that his is going all the way clear, right? So you can see all the acetic anhydride and salicylic acid has reacted, right? So it's all the way clear. So now once it goes clear, you just let it keep heating it for another 5 minutes and it's good. All right. What about you back here? You good? Is it going in? Yep. Hold that up. Yep. So you can see his is gone clear. That means the reaction is almost complete. And then same here. You want to turn that, get that last little piece reacting. Come on now. Keep heating it, because the problem is with the acetic anhydride, if it's not hot enough initially, what you end up doing is evaporating off some of your acetic anhydride, and that screws up the reaction. So that's me.
It's not me.
Somebody, that must be the waiter for my kids. I told them to order lunch while I was here. All right, he's going. You see it starting to go back liquid. It wasn't hot enough. Come on, baby. Now you straight. Now we're cooking with gas. See the difference? If it's not hot enough, it's just gonna solidify because some of that acetic anhydride end up evaporating off. That's really low boiling point. I told you, through the roof. Come on, baby, do right now. That's it. What you don't want to do is take it out and let it cool until it's done. Because if you do, Amari, I think you're done. Let me I need to take some water out of here. So you can, for those of you who are watching, let me turn that camera down. You can actually see now it's starting to go in the solution. You just need to keep heating it up so it'll go all the way. But I need to get some of this water out of here. burn my fingers up. And the reaction itself is not done until it goes all the way into solution. You can actually turn your hot plate off now. And that way it'll still be heating because it's not going to stop heating, but it won't, it'll gradually tamp down a little bit. Yeah, so now you see how it's clear? So now what you want to do is time that 5 more minutes. Once it goes clear, and we're going to take it off and start setting up the filtration. Well, we got to set up an ice bath too, I think. Is it called for ice bath?
Yeah, it's set at 20 milliliters of distilled
Distilled water. Yeah, let me get a graduated cylinder right quick. All right, anybody that's on Zoom, does anybody have any questions about anything? I'll take that as a no.
Will you show the board again with those numbers?
Yeah, let me do that. Can you see the board?
Yes.
Yeah, you can. Yep. So this had this was 138. I think acetic anhydride is what you need. And this was 100.06. Did I say that? And it had a density of 1.06 grams per milliliter. All right, and while you're waiting, you can go ahead and look up the molecular weight of aspirin right here. Acetyl salicylic acid or aspirin. And you can look up the melting point. I see you, bro. I see you.
Oh, I only see portion of the board.
Oh,
Only see a portion of the board.
hold up. What about now? Can you see the whole board now?
Yes. Is the 6.9 the actual amount for salicylic acid?
Well, no, the actual was 6.91.
Okay.
That's the required amount. 6.9 is required. Yeah. So one of the other parts
Is
of
the
this,
amount,
say again?
is the density 6.9 as well?
I couldn't hear that part.
Is the density, is it 100?
No. The density is only going to apply to acetic anhydride. So it's 1.06 grams per milliliter. And then molecular weight is 100.06 grams per mole. Salicylic acid is a solid, so it doesn't have a density.
So you just want us to look up the molecular weight for acetic acid?
Yeah.
Melting point?
Yes. Make sure some. Did I say wait for that cool room temperature? Let that sit for about a minute.
And then I can go ahead and pour this out so we can make the ice bath. Yep.
Repurpose. About what? Which one?
Yeah, you can do the numbers that we have.
Yeah, it's for the people that's on Zoom.
Yeah. You just send it.
Let me get more graduated students.
So your salicylic acid should have the molecular weight of 138. And then your acetic.
Then we're supposed to look at the molecular weight for the salicylic acid and the melting point.
All right.
But that's not, you just write it under the.
So, well, oh, right here. All right, so we're gonna make some, take, the next step is to add cold distilled water. So we're gonna take some distilled water that I stole from our little thing downstairs. And we need 40 mils of this. So I'm gonna put 40 mils in here in the graduated cylinder, and I'm gonna take it off the base and stick it down into our cooler over here. Make sure y'all know now, what y'all see, 40 on the head. Is that right?
Yes, that's right.
Goat status. I just wanna make sure. All right, so we're gonna put that on an ice bath because the water needs to be cold. Because what you wanna do is shock the aspirin out of, shock the aspirin out of solution.
What do we do once this is done? What is 5 minutes?
You can take it off and sit it on the bench top. No, just take the whole flask out, yep. And just sit it down, and once the water gets cool, we're gonna dump it in.
Put ice water in it?
Yeah, I'm gonna put the water on ice. Amara, you can go ahead and add yours. This should be chilled enough. There you go. One thing at a time. Go ahead. I got it. Thank you. So let me show y'all that part too. Like if it calls for cold water, what you can do is, boom, you can just stick the water, take the base off the graduated cylinder and just stick it down into ice, into a cooler or an ice bath or whatever you want to do. Omar added water to his and then immediately turned cloudy. And so what the water does, see, aspirin is not soluble in water. And so what we're gonna do is force the aspirin out of the solution by adding water and then cooling it down on an ice bath. That's the colder the solution gets, the more insoluble the aspirin becomes. So we added 40 mils of water. And so now what we're gonna do is we're gonna put that on an ice bath and watch it crystallize. All right. So this you right here? Yeah. I know what it says in the thing.
Yeah, I got
It's just, you just want to make a little slurry.
you.
That's all right.
Give me that nasty water.
That's all right. Come on, man. Skiggy, man. You gotta go through the paces like everybody else. Have you added your, oh no, you haven't. Your stuff should have been done already. You can take that off. It's been longer than 5 minutes since it went clear, right? Yeah, there you go. Just sit it on the bench top. I know it's kind of yellowish, but it's good. As long as there's no solid left in there, you're good. So you can see that there's no solid left. All of your salicylic acid went into solution. All right. So now we're going to get that water, that cold water, and we're going to zap it. And you can take this. We're going to repurpose our water bath. That's how we do. That's called being efficient. So we're going to take the hot water bath and we're going to dump that water out and put some ice in here and turn it into an ice bath. That's why we work with tempered glass. So you can go between temperatures without having to worry about the glass shattering on you. So we're going to put the water, we're going to add water, and then we got an ice bath set up. And so we're good. So go ahead and dump your water out of your beaker. Yeah, just dump it down the sink. Or dump it, yeah, you can dump it in that sink right there. My bad. You all right? Oh. Don't look at it. Let me show you the trick. I'll just grab it here. Don't grab them on the side. Grab them on the top. It's fine. We're going to put some ice in here.
Get it back. Things you may get it out.
Okay. Oh, I got to get the hose, but that's got to sit for a minute. So we'll do that in a second.
I created that stuff too, so I know where.
You really did. I keep forgetting that. I really keep, I forgot about that. That y'all worked up here. So they used to have y'all like Smurfs. Were they? All right, so you can, let me get the iPad moving. So Kayla, are you ready? You ready for water, right? So we're gonna add 40 mils of distilled water straight to, no, not to that. That's gonna be a wasted trip. We're gonna add 40 mils of distilled water right to the aspirin. So let me move this back so everybody can see. Make sure I don't drop the iPad. All right, so we're gonna add this just right to here. And it's cold water, and you can see it turn cloudy right away. That aspirin is not soluble in water, so when you add that water, the aspirin itself is gonna start coming out of solution. And then when you cool it off, it's gonna come out and crystallize. Right, so that's what we're gonna do now. So we're gonna take that, put it on ice bath, and just let it sit. Right. Just the boiling point, because it's the liquid.
Do you care if it's in Fahrenheit or Celsius?
Hold that. So go ahead and add that to here. Uh-oh. Sorry. I tipped this one over in there. All right, you see the same thing. It went cloudy. It went from clear to cloudy. And now you're just going to sit that on the ice bath. We'll get a little bit of water in there. And then that's going to be that. Boom, boom. So I'll take that back to him. You can just sit that on the ice bath. And I think I'll show you what Amari's is looking like because his is already kind of gone solid. So add that directly to that. Yep. And again, you see it turn white and milky. That's that aspirin coming out of solution, again, because it's insoluble in water. Those aspirin pills that you take, those are not just aspirin. They got all kind of starches and binders in them to make them soluble. So when you take them, they don't fall apart. But when it gets down into your stomach, then all those binders and stuff start dissolving with your stomach acid. And then that's how that salicylic aspirin itself is released. So you can see right here for Amari's, you can see it's like a slurry, right? It went from being a milky liquid to having white crystals in it. So those white crystals, that's your aspirin, but it's not pure. When you make aspirin, a lot of times there's going to be, even though it all went into solution, there's going to be some salicylic acid left over. All right. So that's the purpose of doing the purification, because you want to get rid of that. And the way you do that is to recrystallize it in hot ethanol. All right. So we're going to wait for those crystals a little while. And while we're waiting, we're going to get the filtration part set up. So you can come and help me grab some hoses and some butyl foams. Hopefully we got them. Yeah. See if any of the other drawers are open. It'll be turned horizontal. Keyhole horizontal. Any of those drawers back there are locked. Keyhole horizontal. Right here. All right, I gotta find a filter adapters. Thought they were in the drawer, but maybe they're on the other side.
Huh? No, we haven't written anything. It's a better than what we did.
All right. So for those of you who are tuned in, the next step after the crystallization, which is underway now, is what we're going to do a back infiltration. I think that's on the back side of this handout.
Yeah.
So we need the setup is pretty simple. Let me turn the camera around because this is weird. So for the setup for your filtration, you need a Buchner funnel. It's this little ceramic funnel right here. I'm gonna send y'all a video too, because I got a video with the glassware on it. So you can at least have that. But you need a Buchner funnel. You need a filter flask, which is this. And you can see the little nipple on the side. That's the part that connects to the aspirator on the sink. And that's how you get your pressure, right? Because the sink is gonna pull vacuum once you seal it up. But you can't seal it up without either a stopper or a filter adapter, which is what this thing is right here. So this goes here into your funnel, and then you just sit it down in here, right? And if it's too big, if the filter flask is too big, you can flip it over like that and sit it on top. And both ways you're gonna get back either way. It doesn't matter. All right, I think these filter flasks, the mouth on them is too narrow for these, but we're gonna make it work. Always make it work. All right, so I'm gonna turn this around. Right here, you can see on the sink, you see the aspirator, the little nipple coming off the side. So we're gonna set this up. And got that, yeah. Oh, that's tight. Let's see. Sometimes if your tubing is too small or it's really tight, if you put some water on that little nipple, you'll be able to slide it right on there. All right. And then, so now we got that part set up, and then we're gonna set up, y'all see that? We're gonna set up the flask, and the same thing if the tubing is really tight. You can just wet that a little bit. And that tubing should go right on. Come on, get on there. All right. Now, Once the flask is set up, you can. Let's see if this will fit. That ain't gonna fit. I'm gonna turn it over. The reason I'm turning this the other way is because what you want to do is get a good vacuum, a good seal on there. So when you turn the aspirator on, it's pulling vacuum, right? And because you want to, when you filter it, you want to filter off the water and keep the solid. So we're gonna sit that on top like that, and that's your vacuum filtration setup. All right. So once you get that vacuum filtration set up, you see you can't just, even though it's the funnel is ceramic and the holes are really small, you got to put some filter paper in there. But for us, a lot of times what I'll use is a coffee filter because it's porous enough to let the liquid go through it, but it's tight. It's tight enough so that your solid can go through. No, what you doing? Which one of y'all trying to voodoo me over Zoom, man? Come on. Don't think negative thoughts. You can just hold it like that once we get it set up. All right, I'm gonna take it down for now though, because it don't want to do right. So we're gonna take a piece of a coffee filter, just a regular coffee filter, 100, 200 for $1 at Walmart. And we'll sit that down into here. Now I know it's kind of big, but that makes it better at the end, right? Because then you can just lift it out. And the way if you want to seat it, if it doesn't want to act right, you can always just drop a little bit of water onto the filter to seat it down into the funnel. So let's get those set up for everybody, and we're gonna roll. So we need filters and filter papers for everybody. All right. Anybody got any questions so far? Y'all good?
We're good. Thank you.
All right. Oh, really? That's how you gonna do? Man.
You try to steal it.
No, you got one already. You just need a adapter. Yeah, so on you got a filter plate. Go ahead. Okay, sorry. Let's go ahead and we got that. Let's go ahead and just look up. Go ahead and put that on the end of that. Yeah. Close over that too short. No, it's good. What's your name? Larry. Yeah. All right. Don't struggle with it. Just sit it there for now, and then when you put your phone on top of it, just do like a hold it. Hold it like this. Hold this part like that, and you don't have to hold it. Hold it. All right. So let's sit this down here. So, all right. So I think we got everybody. No, you don't want it to come through. The water's going that way. And, two is gonna pull back. So you don't want any water in your place. All right. So I think we're ready. Thank you. So let's you can take the aspirin out of the ice bath and swirl it around a little bit to get it off the sides and all that stuff. And let me see it before you filter. So this is what you want right here. you want your aspirin to be a white crystalline solid, right? And so since we have that, we're gonna let me see if there's a glass rod in this drawer. Yeah. Sometimes if the aspirin is real chunky, you can break it up. Right? That's a physical change. That's not a chemical change. So it doesn't matter if you break it or crush it. It doesn't matter, right? So we're gonna take this and kind of move it around some. All right. So I got a glass rod, and I'm just gonna chop that up a little bit. So when I get ready to filter it, it'll all come out. There you go. So when you filter it, you're gonna turn on the water supply. Excuse me. And while that water is going, you're just gonna pour that on. And I think don't you have to rinse it twice? 15 or 10 mils. Is it 15 mils twice? 20 mils twice. All right. So go ahead and pour it.
For like all of it?
Just don't dump it, but just pour it on. And you'll see in the flash, you're gonna see the water start to come through to the bottom. Right? Because if you're pulling back on it. So get all the solid on there that you can, and anything you can't get, just turn it over and tap it. Oh, yeah. I'm coming back.
Corn, 20 milliliters in there. And then do what? Put it in here.
Yeah. And then you'll wish it around.
Wish it around and pour it in.
You can add that distilled water straight to the flash. Swirl it around and then just pour it. And it can be more than 20, so don't worry about that part.
We do it twice.
Yep. Because you want to get all that residue. Anything you leave behind is going to cut your yield. So you want everything that you can get, you want it. Here you go, Larry. I'm going to just give you 40, so you don't have to keep coming back. Yeah, you're going to rinse it with this. No tap water. That's what this is for. You're going to add 20, swirl it, pour it, and then add the other 20, swirling and pouring.
It's okay like this.
Yeah, ideally, you want to get everything. Don't leave nothing.
I don't know if I could use some water.
Oh, yeah, the water is not the problem. One more little piece in there, but. Uh-oh. I ain't saying nothing if you don't say nothing. All right. Everybody on Zoom, you straight? Do y'all feel like you're getting a lab experience somewhat? Tom?
Yes, sir.
Good. So when we come back again, next week, we gotta stagger it. I got a general chemistry lab on Wednesday that overlaps with my Wednesday. So I don't wanna have Tuesday come and not Wednesday. So next week we'll stagger it. And then when we come back, it'll be the second set of groups, but we'll be doing the purification part. Need some more?
Dr. Russell, I have a question.
So you're saying your Wednesday, people for Wednesday will stagger the week after the next?
No. The Wednesday lab tomorrow is gonna meet. But when we come back, so next week, we're gonna stagger it. So next week, we won't have an on-ground lab because I gotta do my Wednesday GChem lab. But I don't wanna meet the Tuesday people and then have Wednesday not come because I'm doing the other lab. So I'm just gonna stagger both labs for next week. But tomorrow, the Wednesday people will be here, and they're gonna be making aspirin too.
Okay.
While that's filtering, this is my favorite part of lab, clean up. So
Do
any-
you don't put anything on here? Do you want us to calculate this one?
You can look it up, but since it's catalytic and it's just such a small amount and it doesn't react, all you're gonna need is the molecular weight and the density. Yes. Who? On Blackboard. It's in trying to think what content area. I think it's in lab information. It's in lab information or it's in health information.
So all we're calculating is like the number of moles.
Yeah. So you need the
So
number.
we look up the density of these, the other two that we didn't use.
Well, you need the density only of the liquid.
Okay.
Anything that's a solid, you won't have to have a density. So you can look at
Okay,
density.
because I gave us the ground, so we should be able to get the moles.
Yeah.
Okay.
So the purpose of, for those of you who are on Zoom, the purpose of having the density of your acetic anhydride is because it's the liquid. So you want to be able to go from grams, from milliliters to grams, which you do using the density, and then from grams to moles. So it's very important to calculate those moles because if you don't calculate them, when it's time to figure out what your limiting reagent is and get your theoretical yield, you're not gonna be able to do it. All right?
So we do this last
Oh yeah. Yeah. So make sure you get that handout. It's in course documents, lab weekly experiments. It's the very first PDF document. Make sure you get that and fill it in. Because when it's time to turn in, we're not doing a lab notebook. Everything is gonna be electronic. So you're gonna have a document just like this when we do the recrystallization part. So make sure you get this, fill all the numbers in, and then when we get the crude yield, which we'll get next week, you'll write the mass down, then we'll purify, and then we'll cut, well, not next week after, and we'll purify it, and then come back and get the pure yield, and then you can get your percent yield. All right. So the only thing left today is cleanup. So I'm gonna stop the Zoom meeting. Thank you for recording it. Is it Helynn?
Yes.
All right, thank you for recording it. You can, once you're done recording, it's gonna save on your hard drive.
Okay.
You can just share it on OneDrive with me.
Okay.
I can upload it to Blackboard.
Okay.
Yep. So we just about to clean up, and that's gonna be that. So thank
Question.
y'all for logging in, and I'm glad we got a chance to actually physically come up and do something. So next Tuesday, we'll do another lab simulation because again, the Wednesday lab next week won't be able to meet. So next Tuesday will be a simulation, and then the following week, we'll come back and do our purification part.
Question, Dr. Russell, what time will be for the Wednesday lab?
Same time, 1:30.
Okay.
Yeah.
Dr. Russell, could you help me with the table of reagents? I'm kind of confused with the numbers as to where they go.
So do you see where it says molecular weight?
Yeah.
That's the molecular weight of salicylic acid. It's right here.
Yeah, the 138.12 grams per mole.
Yeah. And
Okay.
then where it says required amount, that's the 6.9 grams.
Okay.
And then for acetic anhydride, 7 mils is the required, and we use a syringe, so it was pretty accurate. So it's 7 mils for required and actual.
Okay.
Molecular weight is right here, 100.06 grams per mole. And then the density is 1.06 grams per mole.
And then for the actual amount for salicylic acid, that was calculated, like
No. What group are you in?
the 3.
Who is here from group 3? Anybody? So you don't have a group person here, a representative? So use 6.91
Okay.
as your actual amount.
Okay. And then
Yeah.
do the same for sulfuric acid.
Sulfuric acid was just 8 drops.
Okay.
You don't have to calculate the moles of that because it's a catalyst.
Okay. And then like the actual amount for that wasn't calculated, correct? You said?
Yeah, it's just 8 drops.
Okay. And then we can find the molecular weight, and there's no density for sulfuric acid because it's a.
You can look it up.
Okay.
Yeah, just Google it.
Okay, no problem. Okay. Thank you.
All right. Any other questions before we log out?
For the melting point and boiling point, do we just look that up and then put them both in the box?
You should
Okay.
be able to Google the boiling point of acetic anhydride because that's a liquid, and the melting point of salicylic acid, which is a solid. All right.
Well, thank you very much, Dr. Russell. Take care.
All right. Y'all take care. And Helen, like I said, just share the video with me on OneDrive. Even if you email it as an attachment, it'll put it to OneDrive anyway because it's gonna be too big.
Okay.
And I can get the link from OneDrive and download it to my computer and put it on Blackboard.
All right.
All right. Thank you so much.